All right, today we're going to tackle one of the most amazing systems in the entire human body, the reproductive system. We are going to build a complete visual map of how this thing works right from the very beginning. I'm talking a tiny embryo, all the way to the super complex cycle you absolutely need to know for your exams. So let's just dive right in.
So this is the central question, right? Think about this for a second. For the first few weeks of life, every single one of us is on the exact same developmental path. We all have the raw materials for both male and female parts. So, what is it? What's that one critical event that acts like a fork in the road and sends us down one of two totally different paths?
And the answer starts right here, with this idea of homologous origins. It's a key concept. It just means that early on, all that internal plumbing in an embryo is completely undifferentiated. It's a blank slate, with all the potential to become either male or female.
Now take a look at this. This is our shared starting point. You can clearly see two different sets of tubes. You've got the Müllerian ducts, those are the precursors for the female internal organs, and you've got the Wolffian ducts, which are the precursors for the male ones. At this early stage, everybody has both. It's like the body is holding two different train tickets and just hasn't decided which one to use yet.
So how does the body decide which ticket to punch? Well, the entire decision comes down to a single, tiny, but incredibly powerful genetic switch. This is the very first, and maybe the most important, step in our entire developmental map. And here it is. The switch is a gene called SRY, and it's only found on the Y chromosome. If that Y chromosome is present, the SRY gene turns on, and it produces a protein called testes determining factor, or TDF. You should think of TDF as the finger that pushes over the very first domino. It is the master signal that says, okay, we're going down the male pathway.
And this slide shows that chain reaction perfectly. So first the SRY gene flips on. That produces TDF. TDF then tells the undifferentiated gonads, hey, you guys are going to become testes. And once they're formed, those new testes become little hormone factories. They start pumping out two crucial things. Testosterone, which tells the Wolffian ducts to grow and become the male plumbing, and Müllerian inhibitory hormone, MIH. I mean, the name says it all, right? It inhibits or gets rid of those female Müllerian ducts.
So the obvious question is, what happens if there's no Y chromosome, no SRY gene? Well, it's actually really simple. None of that domino effect happens. Without TDF, the gonads automatically become ovaries. Without testosterone, those male Wolffian ducts just fade away. And without MIH, the Müllerian ducts are free to develop into the uterus and fallopian tubes. So here is a huge takeaway for your exams. Female development is the default pathway.
And here you can see the final result of that fork in the road. It's pretty amazing, right? From that one common starting point, just the presence or absence of a single genetic signal creates two totally distinct, perfectly functional systems. It's just a remarkable piece of biological engineering. Okay, so this whole system gets built super early, but then it just sits there. It lies dormant for years and years. The next huge event is puberty. That's when the body's central command center finally wakes up and flips the on switch for the whole operation. So let's take a look at how that command center works. So this is the command center. It's called the hypothalamic pituitary gonadal axis. Yeah, it's a mouthful, so everybody just calls it the HPG axis. Think of it as a chain of command. The hypothalamus, which is in the brain, talks to the pituitary gland right below it. Then the pituitary sends orders all the way down to the gonads, either the ovaries or the testes.
And what kicks this whole thing off? Well, at puberty, the hypothalamus starts sending out its signal, a hormone called GnRH, or gonadotropin-releasing hormone. And it doesn't just dump it out, it releases it in these little rhythmic pulses. That pulse is the wake-up call, the alarm clock that gets the entire HPG axis humming and starts the whole cascade of sexual maturation.
Now this table right here, this is your best friend for exams. Seriously, these are the main players. It starts at the top. GnRH from the hypothalamus tells the pituitary, hey, release FSH and LH. Then you've got FSH, follicle-stimulating hormone, which does exactly what it says. It stimulates follicles and sperm to develop. Then there's LH, luteinizing hormone, which is the big trigger for ovulation in females and testosterone production in males. And finally, those sex hormones, estrogen and testosterone, go on to create all the secondary sex characteristics we see during puberty.
Okay, so the system is online, it's active. Now let's see how it actually works day to day. And honestly, there is no better example of this incredible hormonal dance than the female menstrual cycle. It's a physiological masterpiece that happens every single month.
I know this graph can look a little intimidating at first with all those lines going up and down, but don't worry. All it's doing is telling the story of a perfectly coordinated 28-day hormonal conversation. Every single peak and every valley is part of a precise plan, getting the ovary and the uterus ready for a potential pregnancy.
So let's break it down. The first half, about days 1 to 14, is the follicular phase. It starts with FSH from the pituitary, which tells a handful of follicles in the ovary, okay, time to start growing. Usually one of them becomes the star player, the dominant one, and it starts pumping out more and more estrogen. Now this rising estrogen does two main jobs. One, it tells the uterine lining, the endometrium, to proliferate, to build itself up and get thick. And two, it's sending a signal back up to the brain that's getting louder and louder.
And here it is. This is probably the single most high-yield point about the entire cycle. When that estrogen level hits its peak, it triggers a massive, sudden surge of luteinizing hormone, LH, from the pituitary. This is it, the LH surge. This is the direct hormonal green light for ovulation. It's the event that literally causes that mature follicle to rupture and release the egg.
So, the egg is released. Now what? We're in the second half of the cycle, the luteal phase. That empty follicle that just released the egg, it doesn't just disappear. It transforms into a new structure called the corpus luteum. And the corpus luteum has one main job, to produce progesterone. Now, if estrogen was the builder, progesterone is the decorator. It takes that thick uterine lining and makes it secretory, meaning it starts releasing nutrients, getting the bed ready for a potential embryo to implant. If no pregnancy happens, the corpus luteum gives up after about 14 days, hormone levels crash, and the whole cycle starts all over.
So, let's just boil this down to the basics. Follicular phase, that's the building phase. Estrogen is the dominant hormone. The goal is proliferation. Then, the luteal phase, that's the preparation phase. Progesterone is dominant. The goal is secretion. 2 phases, 2 hormones, 2 clear missions. It's that simple. Okay, let's do a really quick rapid-fire review of these hormones, these master conductors, just to lock their roles into your brain. Because once you understand what each one does, the entire process just clicks.
First up, estrogen. Just think of estrogen as the builder. That's it. It builds up the uterine lining every single month. Estrogen equals growth.
Next, progesterone. If estrogen is the builder, progesterone is the maintainer. It makes that lining stable and nutritious, ready for a pregnancy. Its name even tells you its job, progestation. It is the hormone for pregnancy.
Then we have luteinizing hormone, LH. This one has a real moment in the spotlight. It is the ovulation trigger. That massive surge right in the middle of the cycle is the direct, one and only cause of the egg being released. No LH surge, no ovulation.
And finally, follicle-stimulating hormone, FSH. Think of it as the recruiter. It's the one that shows up on day 1 of the cycle and tells the ovaries, all right, let's get a new group of follicles ready to go. It kicks the whole thing off.
So, we've just mapped out this incredibly intricate hormonal dance, a cycle perfectly designed month after month to prepare for pregnancy. But that leaves us with a pretty interesting final thought, doesn't it? What happens to this finely tuned system when it actually achieves its goal and gets paused for 9 months? Or what happens when the cycles stop entirely at menopause? Well, that is a story for another explainer.